So bad.
Okay, so section 4, okay, conservation of mechanical energy. All right, I would like you guys to try those 4. They start out, fairly easy, and then they kind of get a little bit more involved. All right, but there's only 4 of them there, so let's work on those for now and then see where we're at. All right, so on number 15 here, guys, okay, there's this rock and it's released from a height of 20 meters. Okay, so up here, okay, so here's the rock where it starts. It would be at 20 meters, so we could say that would be its initial height. Okay, it's being dropped, so what's its initial speed?
0.
Okay. Okay, ignoring air resistance, in other words, energy is conserved. Okay, determine the kinetic energy, gravitational potential energy, and total mechanical energy at each of the following heights: 20, 15, 10, and 0 meters. Okay, so all we have to do, okay, is calculate basically on our way down how much energy it has at each point. Okay, so what I'm basically doing here is seeing whether you catch this one really, really simple thing. At the beginning, it only has what kind of energy?
Potential energy.
Okay, so if I find the potential energy there, is that the mechanical energy everywhere?
Yes.
Yeah.
Okay. All right, so I'm going to calculate the initial potential energy, knowing that it is also my mechanical energy at every single point. All right, so to do that, I'm going to go m times g times hi, 2 times 9.81 times 20 meters. Okay, that's going to give me 392.4 joules. Okay, so now that I know that, can I calculate the potential energy at all of these other heights?
Yes.
Okay, I don't know the speed at any of these heights. How do I get the kinetic energy? Nope. This is what the question's testing. Mechanical energy is EP plus EK. You already know this number. It's right here. It's not going to change. Can you calculate the potential energy at all those heights?
Yes.
How do you get the kinetic energy? Subtract it. Subtract the potential from 392.4 and you've got the kinetic at every height. You don't need the speed. Okay? All this was testing was, do you remember that mechanical energy is the sum of potential and kinetic? Okay? So what I do here is I say, all right, yeah, my potential here is 392.4 joules. Okay? I'm going to calculate my potential here at 15. Okay? So that'll be 2 times 9.81 times 15. All right, and I get 294.3. All right, 392.4, 392.4, 392.4. Okay, and here I'm going to have 294.3 potential. Okay, over here, I'm going to put my kinetic. Okay, so at this height, my kinetic is going to be 0. Okay, here, it's going to be 392.4 minus that number. So 98.1.
Hit music station.
Whoop, not 9.81, 98.1. Okay, now I'm going to skip down to 0. How much kinetic energy do I have down here? 392.4. How do I know that? Because there's no potential down here at 0 meters.
Get off.
Okay, 0 joules. Okay, now does this question seem pretty simple? Yeah. Okay, but it's mathematically simple. It's not intuitively simple. Okay, it required you to remember a couple of other things that we don't always talk about. We just get into the pattern. Okay, well, the pattern's great. It helps you solve the conservation of energy problem, but we also have to understand where that pattern comes from. That's this. Okay, so for all of these ones, we just calculate the potential energy and then subtract it. So 2 times 9.81 times 10, okay, will get us the 196.2 joules. Okay, and If I subtract that from 392.4, I think I get 196.2, don't I?
Yeah.
Yeah. So there's where they're equal. Okay, and then obviously it all converts to to kinetic at the bottom. Okay, making sense? That's the kind of thing I'd put in a multiple choice question. Okay, it wouldn't require you to do a ton of math, okay, but it would be something like, you know, as the object falls, you know, what's the relationship between kinetic and potential energy? Well, they turn into each other, okay? Or, you know, in a mechanical energy conversion, if something started out with this much potential energy and then lost this much of it, how much kinetic would it have? And you'd have to go, oh, well, I just subtract the total minus this, okay? Things like that, little things that aren't, you know, gonna involve a ton of work, okay? But test, do I understand that mechanical energy is the sum of something's kinetic and potential? Okay? All right, I'll put those questions back. Was there any other ones we need to go over? Okay, I'll put them back up here and keep going.